Okay, now that we have found the stylus, we can go ahead and finish the notes on standard deviation and population, or standard deviation and variance. Because populations are usually too large to gather data from every individual, a random sample is often taken with the hope that it will be a good representation of the population. And that's really what statisticians do. You take small amounts of data and try to use that data to make predictions and draw conclusions about larger populations. It's just the best thing we can do. So to ensure this, the sample must be sufficiently large. And the question is, what is sufficiently large? Well, the most trustworthy is 100 or more, but there are ways of getting around that. We won't learn them in this course, but I'm sure you will in college stats classes. Sample must be sufficiently large and taken in an unbiased way. For example, the last thing I would do is use the average GPA of IB students to try to draw conclusions about the average GPA of the school. That's a biased survey. Because I would imagine the IB GPAs are a little bit higher. Just a little. Okay, how about this? You wouldn't go to Starbucks and do a survey on who likes coffee. I think you've heard me say that before. That's because you're weird, Harrison. I don't like coffee either.
Are IB classes weighted at 5.0 or 5.5?
That I don't know.
I know some people said they had over 5.0.
I don't know.
And they're lying to you.
Anyway, the table to the right shows the notation that's used for samples and populations, okay? So we've already seen X bar and we've already seen mu. Those are the two symbols that we use for average, for mean. The mean of a sample is X bar, and if you're asked to estimate mu, let's say you find X bar is 7, and you're like, so hence estimate mu, you would then write, oh, mu equals 7, because X bar is the best estimation that you have for mu. Now for variance, which you saw us doing yesterday, was Sn squared. That was for a sample. Population would be sigma squared, and of course, standard deviation is just the square root of variance. So standard deviation of a sample is Sn, and standard deviation of a population is sigma. So in general, the population mean, mu, and standard deviation, sigma, sorry about my poor sigma, will not be known. We can, however, use stats from our sample to make inferences about the population. Like I said, that's what statisticians do. Gather data from a small set and try to use it to make inferences about the whole. When a sample of size n, and hopefully n is sufficiently large, when a sample of size n is used to draw inferences about a population, X bar, so mean X bar, is an unbiased estimate of mu.
Shut up.
And I have seen an IB question where on a calculator test, where you had to find X bar using technology, and then the next question said, hence, estimate mu. And it seemed like a difficult question, but all you just did was write mu equals the exact same answer you just found. And Sn is an estimate of standard deviation sigma. Wow, that's a horrible sigma. Yeah, whatever, close enough. I don't make very good sigmas.
How are you supposed to draw sigma at that time?
I don't know.
Correctly.
I'm not sure.
Just drawing the line at the top.
Yeah, that. Me and Greek letters. No, thank you. Standard deviation for grouped data. Yeah. So you can go ahead and type in on your calculator, type in 30 different data values, 40 data values, whatever, and it will calculate standard deviation, mean, and all that crap for you. But when you have a whole bunch of data values like that, life is just so much better when you can represent them as grouped data. So there's a lot less to input into the calculator. So when data is grouped, which would be in a frequency chart, the standard deviation is S sub n equals square root of, and we already have this formula. That's my awful. Well, we sort of have this formula. F sub I means frequency of the term, and then you multiply it by this thing that we talked about yesterday. And then you add all those up. Basically, remember when we were trying to find information about grouped data, we made a frequency product column, and we multiplied the frequency to what the value of the data was, and at the end we added up all of those products. This is the same idea, and then you divide it by the number of things. And good news is, like I said, you're not going to be doing this by hand. Yes, ma'am? Fi means the frequency of the data value. So if I said, let's say we know what mean is, okay? And we know that x sub 3, let's say we know what that data value is, then f sub 3 would have been the frequency of that data value, how many times we had it. So this would have been building our product, our frequency product column, I think that's what we called it when we built them. And then we added up all of those frequency products for the group data, and then we divided by the number. And what we said was when you have group data, that was the best you could do to figure out that kind of stuff. And then please remember, for continuous data or data that has been grouped in classes, we use the midpoint or mid-interval value to represent all the data in that interval. It would be rare that you have all of the information of what's in that stretch, in that class. You won't know you'll know how many things are in it, but you won't know how many are in the middle, how many are at the beginning of it, how many are at the end. So we have to estimate and then just say, look, that's the best we can do, and use the midpoint or mid-interval value. I'm going to say mid-interval value. I like that better than in midpoint. And of course, just like before, we are assuming that the interval is relatively symmetrically distributed. We don't have a way around that. A lot of words in statistics. All right. Then we get some examples, and we call it a day.
Okay.
Catch up with me, panel. There we go. Don't worry, it'll be on the internet. A random sample of 48 sheep was taken from a flock of over 2,000 sheep. The sample mean of their weights was 48.6 with variance of 17.5. Just find the standard deviation of the sample. Hence, estimate the standard deviation of the population, the thing I was just telling you about. I've seen that kind of question before on IB stuff. So part A. You were told to find the standard deviation of the sample. So that's Sn. Well, what we know is that Sn squared is the variance, right? So Sn would be the square root of the variance, which is the square root of 17.5, because they told us the variance. That's about 4.18. And we'll be good mathematicians and put our units on there. So yeah, you were told the variance. You just take the square root of the variance if you want to know the standard deviation. Just so you know, your calculator does not give you the variance. It gives you the standard deviation. So if you're ever asked what the variance is, square the standard deviation, because it will not give you the standard deviation. It will not give you the variance, sorry. So it says, hence, estimate the standard deviation of the population. So we go, so sigma is approximately 4.18. It doesn't have a choice, because sigma is estimated using S sub n. Yes? Yes. It's because, so Sn, this is standard deviation. Sorry about all the letters. And Sn squared, this is variance. Yeah, so if you want to know what the standard deviation is, you just take the square root of both sides. Part B, it says, find the unbiased estimate of the mean. Well, since x bar equals 48.6, mu would be approximately 48.6. Ta-da! It's that easy. It's no work to do. That's the point. The sample information is used to estimate the population information.
And you'd have to use that like square.
No, I just did that because I didn't feel like saying mu is estimated by. So no, you wouldn't have to do that. You could literally write mu equals 48.6.
Okay.
Just because that's the only value you give us.
Yeah, because you don't know anything else about this population. The whole point of finding sample information is that it's used to estimate the population's information. You go, look, that's the best we can do. Yeah. So I've given you a score. Let's just say, since it goes 1, 2, 3, 4, 5, let's just say these are IB scores for a teacher. Not IB, excuse me, AP scores for a teacher, since the scale of 1 to 5, right? So we score 1, 2, 3, 4, 5, and then I have listed how many of each of those were scored in the room. 1, 2, 4, 2, 1. We've been asked to find the standard deviation of the distribution. You see this big old table? We're about to do it by hand. And then I'm going to show you how to do it on the calculator, and you'll never have to make one of these tables again, unless you wanted to for your IA. I'm serious. You don't have to. I've never actually seen it done in an IA, but you could if it meant something. Anyway, fx literally means f times x. So this is our frequency column. This is not our frequency column, our product frequency column. This is fi. This is our product frequency. So it's 1 times 1, 1, 2 times 2, 4, 3 times 4, 12, 8, 5. Oh, I forgot to add straight down, didn't I? This totals 10. And the fx, if you add up 1, 4, 12, 8, and 5, you will get 30.
1,
30.
12.
Now the next column is you taking the x value and subtracting it from the mean. Oh, I better find the mean then, huh? Because we don't have x bar yet. Not yet. We will in a second, though. I'll do it over here. So x bar is the sum of your fx column divided by the number of entries that you have. So our x bar was 30 over 10, which is 3. So the average score in this room is a 3, which really should have been obvious if you look at the distribution. It's perfectly symmetric, 1, 2, 4, 2, 1. So that was obvious. But still, that's how you would have done it in case it wasn't symmetric. So for this column, we're going to do whatever the data value is, and we're going to subtract the mean from it. So 1 minus 3, negative 2, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. You don't add those up because that value means nothing. And now we just make sure that all these numbers are positive by squaring them.
I like this part.
Once again, adding them would do nothing for you.
This is my favorite part.
the last column is you finding the product frequency of the distances squared between a data value and the average. What a mouthful.
So circle 4.
Yes, we're squaring the previous value because we want to make sure that it's a positive number. That's all we're doing is squaring it. So now we're just doing the frequency, which is this column, times the value you just found. So now we have 1 times 4, 2 times 1, 4 times 0, 2 times 1, and 1 times 4. And now we do want that number because remember, the formula required this sum divided by the number of terms, and then we take the square root. So these things add up to 12. Standard deviation is square root of, did I write the formula? I did. Sigma fi xi minus x bar squared, which that number is 12. We just found it, it's 12. Divided by n, which we know is 10 things right here. So we have the square root of 12 divided by 10. So you'd grab your handy dandy calculator and you'd say square root of 12 divided by 10. And you would get around 1.1.
I like 1.
Now, let's do this on our graphing calculator and never look back. Because why would you ever do this by hand when you do not need to? That is the standard deviation. The variance is 12 over 10.
What do we use the standard deviation for?
You don't know what the standard deviation is used for yet. You will soon. The standard deviation, again, at this point, being relatively large or being relatively small, whatever you want to decide as a large or small thing, kind of means something to you. And at this point, it really just means how spread out is my data. That's really all it tells you right now. They do mean things, and we will use them when we've learned about probabilities and things like that. I think in Unit 23, we will come back to them. Okay. So let's use our graphing calculator. Pull a graphing calculator up. Now, you're going to have to bear with me. It's been a long time since I've done this. It's been, well, a year since I've had to do this. I just have to find it. Okay. I believe, just click on Stat. So you click on the Stat button right here. Look where mine is. Click on the Stat button.
Stat button.
Now,
Wait, I can't
you see how it's on Edit already?
Wait,
I'm just.
where's the stat button?
Why don't you look where I'm pointing on the board, Gavin? It's the red button.
Mine's black, actually.
No, it's red because I clicked it.
Oh.
I'm going to hit Enter because, yes, I'm trying to edit my lists. Now, my lists are empty.
This is fancy.
If your list is not empty, pay very close attention to me. Do not go up and press Delete. It will delete the list, not clear the entries. It will delete the list. There is a way to clear it, and I'm trying to remember how to do that. There's a clear list button, but I don't remember.
If you hit stop and hit 4.
Stat 4, clear list. Thank you. Stat, thank you. I was like, I knew there was a clear list button. I just couldn't remember where it was. So stat 4, there, clear list, and you say, yeah, clear my list. Oh, crap.
Maria, you're on probably on mine.
Oh, it wants to know which list. It wants to know which list. So you have to tell it. So like, let's just say I have list 1, second L1. So then I would hit enter, and it would say, okay, we just cleared list 1 for you. Sorry. It's blue, so you have to use the blue key. Anyway.
Wait, stat.
All right, so stat, edit,
Stat.
and now you just put in your quote-unquote X's. These are the entries. So 1, 2, 3, 4, 5.
Then we go to list 2.
Yeah, I just hit down. I didn't even hit enter. I just hit down. You just make sure that you hit enter or down after you hit 5.
Yes, don't hit plus.
Yeah. Then you just go to L2, list 2, and you enter the frequency of each one. So now I understand. Now, right now, all the calculator sees is 2 lists of data. It doesn't know what these 2 lists mean yet.
You can make that the frequency.
We're going to tell the calculator that those are the frequencies.
I typed out 100 terms on one.
100 terms. He typed them out one by one. Holy crap. Yeah, no, you can tell it this is grouped data. Yeah. Yep. So we all there now? We are asking our calculator to do some kind of statistics for us, right? So go to stat, and then scroll over to calculate.
Okay.
Okay. Now, this is one variable statistics, I believe. Bear with me, it's been a year. Yes. The list is L1. The frequency list is L2. Now, if you don't have a frequency list, you would leave this blank. But we do. So we say second, L2 is my frequency
And
list.
now when we calculate.
And then we hit calculate. Wait, how did I get to this screen? Stat, and then go to calculate. Stat calc. It's the second menu. And then it's one variable stats. I'm waiting for everybody. Shh, I'm waiting for everybody to get there before I hit enter. I'm going to hit calculate now. It's going to do some stuff. Okay. Now, if you got something different, that means you typed it wrong. In your list. Go back to your list and check your list.
Oh, I just didn't have the minimum. I didn't see that.
Oh, our screens are just displaying it like yours is smaller than mine. I got you.
Oh, no way.
It worked, right?
Yes.
Okay, now check this out. It shows you your x bar, which is neat. It shows you your sigma x you didn't need. It shows you sigma x squared you didn't need. I would like for you to look at the next 2 things. One says S sub x. S sub x is standard deviation of a sample. Sigma of x is standard deviation of the population. Which one does ours match? Sigma, which is supposed to be the whole population. For this class, SN is what we wrote on the paper, I'm aware. But for IB level that you're at, and I don't know what the other levels do, you are to use sigma as your estimator for standard deviation. I know that that was a sample. You are using sigma. And now that I've said that, I'm doubting myself, so I am going to check a textbook just in case. Oh, wait. Just in case, just in case. Oh, we're still in the red book, aren't we? Ladies, you couldn't hear what I was whispering at home, could you? Okay, good. That means it didn't actually make it to the video. I think I dropped an F-bomb. All right, let's see. By the way, the textbook shows you pictures. Yes, we use sigma. Even though sigma is supposed to represent the population, that's what we use in IB. Cool beans? Yay, technology.